Okay, so what we're going to talk about, the first thing is even and odd functions. And the way it describes it in the book is probably more complicated than it needs to be, at least for the way I want to teach it for you guys. And so the bottom line is this. A function can either be even, odd, or neither. So those are the three states that it can have. And the definition for an even function is that if I put a value of x in to the function, remember a function is I pick the x and then the y comes out. The other, so you pick an x, y comes out, and we call y f of x. And so if I have an x, and then I put the negative of that in there, a negative x, the y values that I get will be the same. So that's a fancy way to say that. So, and the way the book would show it, it would show it that a function, when you're using a negative x, is the same value as a function when you're putting a positive x. So it's really saying that you put a negative x into a function, the y values are the same. So how can we test that? Well, what I recommend you do is just do this. If you have a function, put a 1 and a negative 1 in for x. If you get the same y value out, then it's even. So here would be an example. So if we would have something like, let's say f of x is equal to, say, x squared. So what we could do is we're going to put an x value in, and we could put, and we get a y value out. So if I put a 1 in, 1 squared is 1. I get 1 out. If I put a negative 1 in for x, negative 1, square that, I get a positive 1, I get a 1 out. So what I did is I put a 1 and a negative 1, the same value but plus or minus of each other, and I got the same value for y out. That would be an even function. That's the definition of even. Put opposite values in, you get the same value out. And what that would look like, if you actually graphed an even function, is what you would have is it would be symmetrical about the x-axis. Notice that what's on this side of the x-axis is a mirror image of what's on the other side. So all even functions will be a mirror image around the x-axis. Okay, now let's talk about an odd function. So what happens when I do an odd? Well, what it's going to be is it will be symmetrical about the origin. So it'd be a mirror image of itself around the origin. But mathematically, what's it going to do? Well, we're going to do the same thing. We're going to put some x value in, and its exact opposite, just the negative of that. If I get a value out that are negatives of each other, then that's an odd function. So this would be an example of an odd function. And let's take a look at how, well, first let's do, so I'm going to put x and its negative in. And what I'm going to get out is I'm going to get out some value and its opposite sign. So like a 5 and a negative 5. So they have to be the same value but opposite signs. And how we show that notation is we say that a function, if I put a function and a negative x into that, that would cause the y value to be negative of if I'd put x in. So what these are, remember, this is f of x. This is saying I'm putting a negative x in. This is saying I'm put a positive x in. This negative is saying I get a negative y out compared to the y value that's here. So that's a little confusing. It's easier just to work them. So let's say I have something like y is equal to x. Now they may not have y, they may have f of x, but it means the same thing. So let's say I have x cubed. And so what we're going to do is we're going to put an x in just like we did before. We're going to put in a positive and then it's negative. So let's just try 2 and a negative 2. Okay, so I'm going to put positive 2 into the x cubed. So positive 2 cubed would be 8. And now I'm going to put a negative 2 in there. So if I cube a negative 2, I get a negative 8. And what I see is I put in a number and its opposite. And what I got out were the same y values, but they were also opposite sign. Now, it doesn't matter if I have some equation that I put, like, say, a 2 in, and I get a negative 10 out, and then I put a -2 in, I get a +10 out. It doesn't really matter what the values are. The only thing that matters is that I put in a number and its opposite sign, and I get out something that are numbers and their opposite signs. That would make it an odd. Okay? The last situation would be if I got something out that wasn't either opposite sign but the same value, or the first place where it was even where I got the same values out. If none of that happened, then it would be neither. Okay, here would be an example of that. Let's take this function here and let me just put a negative. Let's just try this. Let's say I've got some function that is x squared plus 1. Oops. X squared plus 1. Okay, so let's make that a cubed. Okay, so what we're going to do is we're going to put in some value of x, and we're going to see what we get out for y. So I'm just going to put a -1 in and a +1. So x, I'll put a 1 in and a -1. So if I put a 1 into here, I get 1 cubed is 1 plus 1, that's 2. Now I put a -1 in, so a -1 cubed, that's a -1. Plus 1 would be 0. So when I put a -1 on, I get 0, and look what I've got. They're not the same numbers, and they're not the numbers that have just opposite signs. That would be neither. Okay, so the three situations, even, odd, or neither. Okay, let's work through some examples. So I'm going to plug in, let's say we've got x. I'm going to put in 1 and a -1, and let's see what I get out for the f of x, which is y. So let's see what we get out. So if I put 1 into here, I get 1 cubed minus 7. So that would be 1 cubed minus 7. So 1 cubed is 1 minus 7. I get out a 6. Okay, now if I put a -1 in, I would get a -1 cubed minus 7 times a -1. That's going to be a -1 plus 7. I get a 6. So I got a 6 out. That would be an even. I don't know. Yes, it would be. I'm sorry. So I got a -6 out. So that changes everything. So let's try it again. Okay, I put 1 in, minus 7. That's a -6. Oh, -6. Well, and then I put -1 in. -1 cubed is -1 minus, that'd be plus. So what I have is I have a -6 and 6. So when I put in opposite signs, I get the same number out, and those numbers are opposites of each other. So that would be an odd function. Okay, going down to the next one. I'm going to put in values of x that are 1 and a -1, and I'm going to see what I get out for y. Okay, so if I put 1 into this, I'm going to get 1 to the 4th plus 1 squared minus 1. That would be 1 plus 1 minus 1. That'd be 2 minus 1. I get 1 out. Okay, let's use the -1. So I have a -1 to the 4th plus a -1 squared minus 1. That would be 1 plus 1, -1 squared is 1 minus 1. I got 1 out. So this gives me a 1. This gives me a 1. So when I put in some number, both it's positive and it's negative, I got the same number out. This would be an even function. Okay, let's do the next one. Okay, so let's put x of 1 and a -1 in, see what we get out. So if I put 1 in here, I'm going to get 1 cubed plus 1 squared. That'd be 1 plus 1. I get 2. So I get 2 out. If I put a negative 1 in, I get a negative 1 cubed plus a negative 1 squared. I'm going to get a negative 1 cubed. That's going to be a negative 1. I have a negative 1 squared is plus 1, and that would be equal to 0. So for this one, the numbers are totally different, so this would be neither.